Okay, cubic functions. Just the simple ones, not the 3-unit type. Y equals x cubed is your simplest cubic function. Do you remember how it looks like? When x is 1, y is 1. When x is 2, y is 8. When x is 0, y is 0. When x is negative 1, y is negative 1. When x is negative 2, y is negative 8. That's what it looks like. We just put a few points in. That's your cubic. Do you think it's an odd or an even function? All right, let's just do that while we're here. Okay. So what's your domain? What's your range? And we think it's odd as it has point symmetry, but we're going to prove it as well. Okay. Domain, any restrictions on x? There are no asymptotes. And any restrictions on y? No. Domain, all real x, range, all real y. It is odd as it has point symmetry. We can see that, but what's the rule for odd? Function of negative x is, so that's your function of x. So your function of x is x cubed. What's your function of x? Negative x? Negative x all cubed, which is negative x cubed. Doesn't that equal negative whatever the function of x is? Or do you like to write negative function of x separate on a new row? You can do it either way. Which equals the negative, and x cubed is the function of x. So therefore it's odd. An odd function as the function of x, negative x equals negative function of x. Why did I not do this for circles? Circles aren't functions, but semicircles are. Okay. And semicircles actually, do you think, we'll just have a quick look, that semicircles, if you do go back, they're even functions, semicircles. Do you see? Semicircles are even functions. And you would find that function of x equals function of negative x for those. All right? Because if you substitute it into something like this, y equals 9 minus x squared, you know the x squared would be negative x squared. You end up with the same thing. Okay? All right. Just another example. Y equals x cubed minus 2. What is this function? This is y equals x cubed shifted where? Down 2 units. So a quick sketch. Instead of this is called an inflection. Later you'll learn about that. At 0, 0, it'll happen 2 units down. So you must put that point in that it's negative 2. Might be nice to put in the x-intercept while you're there. So it looks like that. This, or you can put this one in, when x is negative 1, y is, and I wouldn't mind putting in this x-intercept here as well. So, what do you think? When x is negative 1, what's y? Negative 3. And when x is 0, sorry, no, when y is 0, x cubed is 2. X is the cubed root of 2. So this is the cubed root of 2, that x-intercept. Not that it, it's just for sketching purposes. But it would be enough, like if they asked for the x-intercept, yes, you'd have to put it the cubed root of 2, not 3 root 2, small little 3. It'd be good even just to put the y-intercept here as negative 2, and negative 1, negative 3 is good too. Okay? Domain and range? Any change? No. No restrictions. All real x, all real y. And we'll look at another example. Y equals x plus 1 cubed. And then we'll do another one. Y equals x minus 2 cubed plus 1. So we're doing 2 more. The next example, x plus 1 cubed, because it's x plus 1 in the brackets cubed, it is the shape of x cubed, but shifted. So this is y equals x cubed shifted 1 unit to the left. So just the same shape, But be careful. Let's just put the y-intercept before we start. When x is 0, what's y? 1. When x is negative 1, it's 0. What about when x is 1? 8. Y is 8, so it goes like that and down. So I'm going to put this point in, it's 1, because when x is 0, y is 1. The curvy bit, the inflection bit is at x is negative 1. What about this? What's this point down here? What do you think? Like I sort of went across 1, up 1. What do you think? Negative 2, negative. That's negative 2, negative 1. Because when x is negative 2 plus 1 is negative 1 cubed is negative 1. So I've just put 3 points there. No change again to the domain and range. Why? Because there's no denominator. There's no restrictions. There's no restrictions on what x can be. And what's this last one? X minus 2 cubed plus 1. This is y equals x cubed, shifted 2 units where? 2 units right and 1 unit up. So 2 units to the right would take me to 2, 1 unit up. So it's got to look like this, but we need to know where this other... See, look at the very original one. Look, 1, 1, negative 1, negative 1. So from that inflection, that curvy bit, you've really got to go across 1, up 1. This should be the point 3, 2. If this is the point 2, 1, let's just have a look. When x is 3, what do you get? 3 minus 2 is 1, cubed is 1, plus 1 is 2. And this one is, it should be that. It should be 1, 0. When x is 1, 1 minus 2 is negative 1. Negative 1 cubed is negative 1, plus 1 is 0. This other one, but what about when x is 0? What do you get? You get negative 7. So you might want to put that in as well. And an arrow up there. So, actually, I might just do it on this one. I'm going to do, all right, we know it's, can you just give me, so give me the range if the domain is 0 less than or equal to x less than or equal to 4. Okay, I want the range if the domain is from 0 to 4. So, well, I've already done one of the points, do you see? I know that when x is 0, y is negative 7. What about when x is 4? I just have to work that out. When x is 4, what's y? 4 minus 2, 2 cubed, 8 plus 1 is 9. So that's all you do for those if they ask. So I'm just going to stop the graph, and up here I would go up to 4, 9. I know it's not to scale, okay? All right, so if you're asked on any of the types of graphs, and here I'm going to stop there at negative 7. So the range will be, if I've got a restricted domain, would be from negative 7 less than or equal to y less than or equal to 9, if the domain is restricted. Okay, you just need to know where the endpoints are. You just substitute your two x values into your equation to see where it starts and ends. Sometimes they will be the lowest and the highest points, but if it's a parabola, as we saw earlier, they won't be the lowest and highest points. You just, well, that's a cubic, that's okay because you know the shape. But if it's a parabola, you've got to see where the vertex is. Okay? Yeah.